Hi, I'm Jordan. This is my assistant. Britt. Hey, Britt. Now, we're here today to talk to you about math and how it's used in the real world. Let me ask you something. Do you drink water?
H2O?
Precipitation?
Liquid ice? Maybe a little bit of Wawa?
Maybe. Whatever you call it, sounds like this stuff is pretty important. And
So what's keeping this so clear, Jordan?
That's a good question, Britt. And I think I might know who has the answer.
Who?
Dr. Martin Locke at the National Sedimentation Lab.
Where?
Just go.
Okay.
My name's Martin Locke, and I'm a research scientist at the National Sedimentation Laboratory. I'm a research leader and a soil scientist. That's my scientific discipline. And I work for the Agricultural Research Service, which is the research arm of the U.S. Department of Agriculture. Well, as a soil scientist, I'm very interested in preserving and sustaining soil as a resource. My job is to look at ways that we can conserve and enhance our soil and water resources. What is water erosion? Well, when it rains and the soil is bare, it becomes vulnerable to being eroded or washed away. We want to try to find ways that we can help reduce the amount of chemicals and sediment that make their way down the river. Every time you till the soil, you expose it to the elements. You expose it to rain, and which can cause water erosion, or even wind erosion can blow the soil. Anytime you have a bare soil, it's vulnerable to erosion.
Thanks, Dr. Locke. You really know your erosion.
Yeah, erosion.
Yeah. Now we're going to go to our reporter in the field, Houston Settle, who's going to give us a first-hand look at wind erosion at its finest.
Erosion time.
Yeah. Calm down, man. We'll get there. Houston, how's it out there, man?
Woo! Woo! I love this stuff.
Well, no, it really looks like he's in danger, man.
Oh.
Maybe we should help him out. Should we freeze it up?
Yeah.
Freeze frame?
Uh-huh.
Ready?
Yeah.
Ready?
Yeah.
Yeah. Freeze frame!
Hey, thanks guys. I guess what we're really trying to figure out here is how much soil is actually being eroded. Well, we can figure that out with a few simple math equations. Let me explain.
Did you know we can actually compute how much soil is being lost by using math you learned in school? For instance, the area here approximately equals or resembles a rectangle. Approximately equals means almost, not exactly, but pretty stinking close. So, for the sake of working the problem, we'll call it a rectangle. Oh, and you might be asking, what's a rectangle? Well, a rectangle is any quadrilateral with 4 angles. Kind of like a square, but don't confuse a square with a rectangle. You see, a square is a rectangle, but a rectangle is not always a square. Stop. Take a moment and see if you can tell me the difference. Well, let's see how they're similar. A square has 2 sets of parallel sides, and so does a rectangle. Do you know what parallel means? A square has 4 90-degree angles, and so does a rectangle. And remember, all squares have 4 equal sides, but not all rectangles have 4 equal sides. So, to find out how much soil is being lost or eroded, we need to think in terms of volume. To find the volume of the soil erosion, we need to multiply length times width times height. The length times width actually tells us the area. Sound familiar? Area equals length times width. This tells us the area of a rectangle, which is represented here. In this case, the length is 800 feet and the width is 300 feet. So, if you multiply them, you get 240,000 square feet. Now let's assume we're losing a ½ inch of topsoil a year. A ½ inch is the same as 1/24 of a foot. So if you multiply the area times 1/24 of a foot, that tells us the volume of the soil being lost or eroded. By the way, that comes to 10,000 cubic feet. If you want to know how much that weighs, we can convert it to pounds. Let's assume 1 cubic foot of soil equals 50 pounds. So, to figure out how many pounds of soil is being eroded, multiply 10,000 cubic feet times 50 pounds per cubic foot, and you get 500,000 pounds. Now that's a lot of soil erosion. Can you imagine just 1/24 of a foot per year of soil from that small of an area comes to 500,000 pounds? Now that's a lot of erosion.
So by reducing tillage or by practicing conservation tillage, you can help to reduce erosion. Another way is keep a cover on the crop or on the soil. So we do this by planting a cover crop during the fallow times. After you've finished harvesting your crop in the fall, you might till it up and then plant a cover crop that grows during the winter and protects the soil during the time when the crop's not there. Another way that we use to help reduce erosion is to plant buffers around the fields, so that if you have water runoff coming through the buffers, the buffer acts as sort of a trap to slow the water down and to stop the sediment from being lost. Another one is the slope of the topography. If you have a steep slope, obviously the water is going to run down the hill faster with gravity, and you're going to have more erosion. Another thing that affects erosion is the intensity of the rain. If you have a nice, soft sprinkling of rain, you're not going to get much erosion. But if you have a hard, intense rain, it's going to tend to erode the soil a lot more.